Wednesday, for the first time all semester, Zeke, you're 5 seconds into class. So for the first time all semester, we can see the bottom of my calendar, which makes you sad, I'm sure, because it means the semester is winding down. So we are in the middle of our 4 classes on finance. So today is class number 2. We'll talk about compound interest. 2 more classes on finance coming up next week. 2 this week, and then next week after Thanksgiving, 1 more on finances, 2 on fractals, a to be announced day, and then a review day for our test. The 3rd test is scheduled during final exam week, but it is not a cumulative final exam. It is just a 3rd test. Right? Questions on the calendar? Ricky? We don't have a final exam. We just have a 3rd test on the new material. Sue-Ann?
So if there's no, because there's a to be announced day, if there's no school Wednesday,
Is there snow scheduled?
Yeah, we're like under a winter storm watch from 7 a.m.
Oh, okay. All right. Yeah. So the to be announced day is here in case there's a snow day. So if there's a snow day Wednesday, then yes, everything will get pushed down a day. Great. Question? No. Okay. One other thing here. One other thing is the project. So again, technically not assigned until Wednesday coming up, but I've handed it out to you. So make sure you grab a copy of that project. This project you are going to turn in just that physical hard copy, but with all the questions answered. The project is not due for a little while. December 8th is when the project is due. But if you're able to get started on it, you might be able to bang out a lot of it over the Thanksgiving break, right? Thursday, Friday, there's no classes. Does anybody normally have a Wednesday night class? So not this Wednesday. Wednesday night classes are canceled right before Thanksgiving, okay? So don't go on Wednesday night coming up. 4 p.m. is the cutoff for day and night. All right, the finance project is assigned, and I just want to point out that there is an Excel component to this project, but it is different from the Excel component of project 2, which was about apportionment. This one, you're not creating an Excel document. You are going to use a document that already has all the formulas typed in, and you're just going to change the numbers to answer the questions in the packet. And where do you go to find the Excel documents? Moodle. That's the only place you will find them, okay? There are 2 documents. They are referred to by name in this thing, and it says here, go to Moodle, find the document titled blah, and then just play with it to answer the questions, all right? Okay, from what I've heard in past semesters, this is the easiest of the 3 projects, but don't let it linger, right? Just chip away at it. There are a lot of questions. There's nothing really terribly difficult, but there are a lot of questions to go through. Okay, so we're back here on page 11. And we'll start with a quote from Albert Einstein. Eric? Okay, let's go to, who's ready now? Zeke, number 1. Okay, so we talked about simple interest last time. Compound interest is this new, it's a way of calculating interest where you get interest based on previously earned interest. So number 2 is an example. Jeff? Okay, thank you. So let's try the 1 year later business. So we had a formula from last time that said this. If you want to know how much money you have somewhere down the road, you take the principal and you multiply by 1 plus the rate times the time. You used this formula in our last class on Wednesday. So in this example, what's the principal? It's 5,000. That's how much we start with. Times 1 plus, what's the interest rate? This 0.06, right? We always have to convert our interest rates to decimals. And if we're just going to let this thing run for 1 year, then the time is 1 year. So I'm not even going to put the time in here. I'm just going to leave it like that. Let's say 5,000 times 1.06, and we could do that without a calculator, right? 6% of 5,000, let's see, 500, 5, is it 300? So is this 5,300? Somebody help me out here. Yes, okay. All right, so that's how much money we have at the end of the first year. And then we look at what happens by the end of the second year. What is the principal at the start of the second year? Is the 5,300, right? You have 5,300 in the bank, and that's what you're going to earn interest on. So instead of being at 5,000, you're now at 5,300, right? And this is the idea of compound interest, is that you're not just getting interest on the original 5,000, but you're now going to get interest on the $300 you made in the first year. And so we multiply this together. What do we get on this one?
Do we not have to do it times 2 years?
I'm doing this 1 year at a time.
Oh,
And so I'm updating my principal so that I just start over every year. 18. Okay. How much interest did we make in that year? 318, not just the same 300, but 300 plus the $18. Where did the $18 come from? This 18 was the interest on the 300 extra that we earned in the first year. Okay, and so we could play this game, we could go to the third year and the fourth year, but we want a formula so we don't have to keep generating this every year. And the idea is that if we just take the principal and multiply it by 1 plus r and then raise it to the time, turns out this is going to give us our answer, and we'll confirm it for t equals 2 years. So let's go back to the beginning of this problem. What's the principal? It's 5,000. Interest rate is still 0.06. And suppose that we just wanted to figure out what was happening after 2 years. So what I claim is that we just need to do this 1.06 squared. Why is that true? Well, in blue, we took the 5,000 and multiplied it by 1.06, right? And then we took that answer, the 5,300, and multiplied it by 1.06. So in effect, we just took the 5,000 and multiplied it by 1.06 twice. Do we see that? And if we want one more year, it would be 1.06 times 1.06 times 1.06. So I think it's quite natural for the time to sort of end up as an exponent. And so if you crunch this in your calculator, hopefully you get the same thing, at 5618. So then if I'm looking for this t years later business, I think we can just say, again, using the formula in black, what's the principal? Start, it's 5,000. 1.06 to the t, whatever t is. You can plug in any number, but I think that's our generic formula there. Okay, so now that we've got our formula, I want us to use that formula to fill in this table right here. So you're going to use your calculators and maybe split up the work at your table to try to fill in all the numbers in this chart. And then same formula. Use the red formula for the whole chart. And then you're going to plot points for the first time all semester and see what kind of a curve we get. Again, feel free to divvy up the work. I don't need everybody to do every one. All right, so let's come back together. I think everybody's plotted some points, and then we connect these dots, and we see this curve that grows kind of slowly in the beginning, but then grows very quickly when we get 30, 40, 50 years down the road. Let's move on to the next page. I actually jumped the gun a little bit there, but here's the formula that we wrote down on the previous page. So go ahead and copy that guy in the box. F stands for future value. I was using A for amount on the previous page, but the future value of some money invested called the principal is given by that formula. It's the same one that you guys just used. Okay, so let's go to Jennifer for number 4. Thank you. Okay, so we're going to use our formula here because this is a future value problem. So what's the principal? There's a lot of numbers in this one, but how much do we invest initially? It's 875. And then we multiply by 1 plus interest rate is. So how do we write 6.75? 0.0675, right? Make that percentage into a decimal by moving the decimal point 2 places left. And then we raise it to the time. How much time is elapsing in this problem? 7.5 years. And the nice thing is you can just type this thing into your calculator just as it sits. You don't even need to do partial calculations. Just type that whole thing in just as it is. And we don't need everybody to do it, but just one person and one confirmation. Who's got an answer for us? Anybody else confirm 1428? Okay, so that's how much you have in 7.5 years. What was this business about the 2000? That's how much we want. So we're short by about 600, a little less than $600. So what if we didn't want to be short? Like what if we knew ahead of time, because we did our work here, that we were going to be short? Well, you could either try to find a bigger interest rate, or you could maybe make it so you waited a little bit longer. Maybe you can wait a little longer than the 7.5 years, or you put more money in the bank today so that it will grow to the 2000 when we need it. So let's try answering that question. In our blue formula, where does the 2000 go? It's the F. It's the desired future value, right? So we're going to use that formula. 2000 equals, what's the principal? That's what we're trying to find. We want to know how much could I invest today so it grows to the 2000. Everything else stays the same because the interest rate is the same and the time is the same. So all we're doing is trading in the principal for an unknown, and then we can do some algebra to solve this thing for P. Okay, so we're going to get some rounded number here. I'll do this one on my calculator on the board. So we need the 1.0675 raised to the 7.5 years. Yeah, so I'm just going to round to the nearest hundredth in my answer. I'm going to write down 1.63. But then I'm going to make sure that I don't round on the calculator. I'm going to let the calculator store as many digits as it's showing me, plus a few more that it is not showing me. If I were just to type in 2000 over 1.63, I'll do it right now. 2000 divided by 1.63. This is, oopsies, 2000 divided by 1.63. This is going to be something close to the answer. I get $1,227. That's how much I should invest today in order for it to grow to 2000. But really, if I want to use my calculator to its fullest capability, then I should leave that number on the calculator, and instead I should type in 2000 divided by that thing. And so on my calculator, I have a little button that says, you can't read it from where you are, but this yellow thing right down here near the bottom says ANS, which stands for answer. So you might have a button that says ANS. And so if I access that yellow ANS, then it says, oh, he wants me to divide by the previous answer. And so this is going to give me a more accurate answer, the most accurate answer this calculator is capable of. Okay, so how much difference are we talking? It's like less than $2 different, right? We're not talking that big a deal. But that's just because these are some small scale numbers. And so there's no sense in getting a less accurate answer than your calculator is capable of because you felt like retyping 1.63. So part of what I'm after here is that we can use the calculator to its fullest potential, okay? And I'm happy to show you how to do it on yours if it doesn't quite look like this. So our answer here is that P is equal to the 2000 divided by the 1.63, and we got 1225.38. Questions on that one? Okay, so let's move on to Matt for number 5. Okay, so let's try this guy. So instead of getting the interest once at the end of each year, we're going to get it once at the end of each month. So in order for the bank to still be giving us this annual 6.75% interest, what would we do to that to figure out what the monthly interest should be? Divide by 12? Yeah, like that's a reasonable thing, right? If we're going to get interest every month, we're not getting 6% interest every month, we're getting 1/12 of that. So that seems fair. And so I'm going to write down something here, and then we're going to write down a formula that we'll just be plugging into. The principal, I think we're back to the 875. This 1 plus 0.0675 should now include a divide by 12. We should take that interest rate and divide it into 12 equal pieces. But then the thing that goes in the power, it used to be time in years, right? 7.5 years, but that's not the appropriate unit of time anymore. We should put months up there. So how would I find out how many months in the 7.5 years? 7.5 times 12, yeah? Like that's how many times we're going to get interest, once per month. So then I think it's quite natural for us to put up here 7.5 times 12. That's how many compounding periods there are, that many months. Okay, now there is a real easy way to type this in wrong, so we want to avoid that. Okay, so I got my power button for me is right there. So here's the spot that is easy to make a mistake, is that it's tempting to just put exactly what it says over there, 7.5 times 12, right? But the calculator is not going to do what I wanted it to do, which is in black, because I didn't tell it to do this. We know that 7.5 times 12 is all in the power because that's how we wrote it, right? But the calculator at the moment has no way to know that we mean all of this is in the power. So what do I need to install or insert? We need parentheses. Yeah, could put the actual number. We're going to put parentheses around the 7.5 times 12 because the calculator thinks that I want to take the whole answer and multiply by 12 at the end. And that's not what I want. That's what it would tell me if I hit enter right now. So we need it to be up there. And so we put in these extra parentheses that aren't necessary when you write it, but are necessary when you type it. Just like that. So this will give us the right answer. Before we hit enter, how much money did we have when we played this game before? It was $1,428. That was when we got interest once at the end of every year. Should this number, where we get interest every month, be more or less than the 1428? Should be more because you're going to get interest on earlier interest sooner. So is it more than 1428? Yeah, about 20 bucks more. Okay, so that's our 1449.62. I'm going to round to the nearest penny. The rounding that we wanted to avoid is rounding internally during the calculation, but we typed it all in one shot, so we got the best answer we could. Okay, so we got that, and then now in number 6 talks about compounding daily. So let's see if we can update our formula to take care of this happening every day. So 875, stays or changes? Stays the same. Parentheses, 1 plus 0.0675, stay or change? That stays. Divided by 12, stay or change? Changes, because now we are doing daily. And so if we cut our interest rate into 365 equal pieces, then that's how much interest we should get every day. So it's only fair. And then upstairs, it used to be 7.5 years, but now we should be measuring time in what unit? We should be measuring it in days. So the question is, how many days in 7.5 years is 7.5 times 365? Yes? And so maybe you can see there's this formula that's just kind of waiting for us to write down, where like it's just 12 and 12 in those spots, 365 in 2 spots, and whatever compounding period you want in 2 spots. Anybody have a number for us here? Anybody else have a number for us? $1451.61. Yeah, we didn't get very much more, right? We made 20 bucks extra the first time, and then when we went to daily, we made only another $2.
I got the numbers in.
Keep going.
Oh, I know what I did.
Okay, on the next page, I think it asks us to do another calculation like this, but probably that's enough. I don't know. What would we do twice a day? How would 365 change if we want to compound twice a day? We just times it by 2, right? So this 365 in 2 locations would just get doubled in both locations. We would get a little bit more money, but really not that much more. If I wanted to do this compounding every hour, what would I do? 365 times 24 every minute. Yeah, so actually that last one, the most ridiculous one, that's the only one I want to do. So let's try this last one here. So we're going to compound every minute. So you imagine that you put your $875 in the bank, and then every minute you get a little ding on your cell phone. It says, oh, you just earned another 0.2 pennies, right? And it's just like every minute you get this update. Okay, so we'll use our formula. Still 875. Still 1 plus 0.0675, but now we need to do a big calculation to figure out what goes in the bottom. So this guy down here, how do we calculate this? 365 days times 24 hours times 60 minutes per hour. Okay. 525, 600. That's how many minutes in a year. Yeah, what was the rent calculation? Was it hours in a year? Was it minutes in a year? What was it? Was it this number? Yeah. Oh, good. All right, so they got it right. 525, 600 goes there. And up in the power, normally it's 7.5 years, but we're looking for how many minutes in 7.5 years. So times. So we'll put that 525, 600 up there. All right, so who's got the final number for me here? Oh, that's the product up there. Yeah, that sounds fine. I want the whole answer when somebody's ready. 1451.67. Okay. So how much extra did we get there compared to the previous calculation we did? That's 1451.67 down here. 1451.61. So 6 cents. Right. So yeah, so it turns out that even if I give you like fractions of pennies, like every moment of the day, you're not going to be a millionaire at the end of the year. It doesn't matter how often I give you this money. It seems like we're kind of leveling off at some like theoretical, like best case scenario. And so, so let's go ahead and write down, let's see. Is there a place we were supposed to write this formula, or do we have it? Oh, there it is right there. So this is basically the formula that we've been using at the bottom of this page. P1 plus R divided by something times T to the something. That N is how many times you compound money per year. So when we did this daily, N was 365. Right? So the only new thing in that formula is the N. So when you take your test next month on this material, you'll have all these formulas on a reference sheet, and we'll look at the reference sheet in a few classes, but Here's another one that's getting thrown onto the pile. And so let's take a look at number 11. I think we'll go to Christopher. Okay, so if you see a problem where it says the word continuous, then you're going to be using this new formula that we are about to see. The only time you get to use this formula is if the word continuous appears. And continuous just means not every second, not every half second, not 1,000 times every second, but continuously at every moment in time. Right, so more often than any small part of a second that you can name. That's what we mean when we say continuously. And so it turns out that the crazy formula we've been using, the one that we used up here with the purple and black, becomes this thing. So the future value is the principal, that's the same thing. And then there's this mysterious E, which we have never seen. And then RT, okay, RT at least, the R is the rate, the T is the time. We haven't seen them multiplied together in any formula, but for some reason they are here. And this E, even though it looks like a variable, like all the other letters in this problem, it's actually a number. And E is about 2.7 and change. And it's such an important number that we give it a name. We call it E. Just like pi is an important number, and so we give it a name, right? It's pi. You guys know pi means 3.14 and then a lot of other digits. Same thing with E. It means 2.7 and then a lot of other digits. It goes forever, and there's no pattern in terms of these digits here. And so to figure out why this mysterious number comes in requires calculus, so we're just going to accept it for this course. But let's see if we can use the formula and answer the same kind of question we've been doing. We'll start with $875, 6.75% compounded continuously and in 7.5 years. What word tells us that we should be using this E formula? Is continuously. So we do F equals PE to the RT. So P is still 875. E is a number. You don't replace it with anything. It's just E. Just copy it. And I'll show you where it is on the calculator. R is still 0.0675 times, and then up there's a T. T is 7.5 years. So that's it. So I really like my virtual graphing calculator up here, but it emulates the real calculator so well that it auto shuts off after like 5 minutes, which seems quite ridiculous because there's no batteries to save on this thing. But anyway, we got to pull it back on. Okay, so we're typing this thing in. So here we go, 875. Now on my calculator, again, I don't know that you can see it, but I have an E to the X button. You guys might have an E and then a caret button. So you're looking for one of those options, but you should see a lowercase e to something button on your calculator. So second that guy, and then I just type in the 0.0675 times 7.5. Notice my calculator was smart enough to include parentheses as a default. So if yours didn't, you better put them in right now. 0.0675 times 7.5. So that's how we type it. Calculator knows that E is about 2.7. And we get that. Does that number look familiar? Yeah, that's really close to what we had for our last answer. So I can help people with calculator issues, but
I did it out with my calculator.
all right, yeah, I'll take a look at calculator issues while you're working on the group stuff. But about 1,451 and 68 cents. Okay. Yes, I will look at it, but not at this moment. Okay, I'll take a look at it in a little bit. All right, so that is the continuous compounding. Again, I'll help with calculator issues while we're doing the activity. Okay, last concept here starts with 13. Can we go to Sarah for 13? Okay, now let's go to Megan for 14. Okay, so let's give this a shot. So we're looking for what percentage will get us from 1,000 up to 1,099.60. So we can use the same kind of formulas that we've been using today. So our formula is, I'm just going to write down one of the easier ones that we had was this guy. Yeah, so we saw this formula earlier today for the future value where we weren't compounding monthly or daily or anything. It was just once at the end of the year. So I think we can use that here. And in this problem number 14, how much is F? Is the 1099. That's the future value. Equals, how much is P? It's 1,000. So we start with 1,000 and it's supposed to grow to 1,099. And then we do 1 plus R. How much is R? We don't know. We're trying to find the interest rate. What did our money actually do? And then T is how much time elapsed, which was 1 year. And so I think we have enough info to solve for our rate. Okay, so you have two choices here. Well, I'll write it without the power first. So I didn't write to the first power. So two choices. You could either distribute that 1,000 or you could divide both sides by 1,000. And it turns out to be easier to just divide by the 1,000 than to distribute. So if we divide both sides by 1,000, this side becomes 1 plus R. This side, 1099.6 divided by 1,000. Dividing by 1,000 has what effect on the decimal point? How many places over? 3 places. So let's move this thing 3 places to the left. 1.09960. And last step to solve for R. Subtract the 1. So we get 0.09960. As a percentage, 9.96, right? Because we know decimal to a percent, move that decimal place 2 to the right. Okay, so 9.96% was our APY. Okay, so what you are going to do, there's no formal activity. There's number 15 here and number 16 on the next page. You're going to work on those two and then get started on the homework. So we have a good 35 minutes. So you should be able to take a big chunk away from the homework if we work through the period. I'll come around if there were homework questions.